We next look at random variables. Random variable is just a numerical measure of the outcome of an experiment. Its value is thus determined by chance. Random variables are typically denoted using capital letters. The most commonly used one is a capital X, but we will mix it up depending on what the variable is measuring. Well, there are two types of random variables, right? So if you notice, a random variable is always going to be quantitative, right? What are the two types of quantitative variables? So you have discrete random variables and continuous random variables. Right, and it's same as with discrete quant versus continuous quant. So discrete random variable is either countably infinite or finite, typically speaking, whole numbers. And then continuous random variable has infinitely many values. Again, typically speaking, it's going to be over an interval. A full in-depth analysis of both discrete random variables and continuous random variables does require Calc 2. As we'll see, discrete random variables are typically sums. Continuous random variables are areas, but areas are integrals. So for the time being, you'll just have to accept everything we say. If you do take a more advanced stat course, a junior level stat course, you're actually getting to that, because that does require Calc 2. A probability distribution provides the possible values of a random variable as well as the corresponding probabilities. Right. They can be in the form of either a table, a graph, or a mathematical formula. Mathematical formulas, we'll call them like probability functions. Rules for distributions. Right, so again, we have capital P of X, that's the probability that the random variable takes on the value X. These are going to be for discretes. We're not really going to delve into continuous at all because that is strictly integration, which is count. At least with finite sums, we can understand it. The sum of all probabilities has to be 1. And each individual probability has to be between 0 and 1. There. Probability histogram is a histogram in which the horizontal corresponds to the value of the random variable, and the vertical is its probability of occurring. Right? This is identical to the relative frequency histograms that we looked at. Well, random variables are distributions. There are two measures that are of particular interest regardless of the distribution. Every distribution, you're always going to want two specific measures. The mean and the standard deviation. Mean is also called expected value. There are two ways to denote expected value or mean. The first is using a notation I'm familiar with, mu, right? So mu sub capital X means the mean of the distribution of X. And again, this is only for discrete random variables. It's the summation of X times its probability. So take each value that the random variable can take, multiply it by its probability of occurring, sum all of those up. That is your average value. Another way of representing the mu is this. E of X to represent the expected value for X. By expected value is the average outcome if the experiment is performed a large number of times. Right, this leads to the law of large numbers. If we sample from a population, then as the sample grows larger, the sample mean will approach the population mean. Second, standard deviation. But what is standard deviation? We didn't look at standard deviation first, right? What did we look at before standard deviation? What was it? True, but how do we get standard deviation? What measure did we derive it from? Standard deviation is the square root of what? what were the measures of spread? There were 3 of them that we studied. Standard deviation is one of them. This is big because we're using it a lot, so we need to know. Hmm? Sample is just what you're surveying. It's a subset of the population. Now, of course, standard deviation does have 2 forms, right? Sample or population dependent. What is it? Variance. Again, there are 2 notations. Sigma sub x squared, which corresponds to what we use to measure population variance, right? Sigma squared. Or V of x. Its formula, sum of x squared times p of x, so square each value that the random variable can take on, multiplied by its probability, sum them all up, minus the expected value squared, or it's more commonly expressed. E of x squared minus e squared of x. And standard deviation, just simply the square root of variance. And we can also represent standard deviation as SD of x. And generally speaking, we just find the variance first, get a value, and then take its square root. So that formula under the square root, we're going to ignore for the most part. So a few things. Key takeaways. Discrete random variables, countable. Continuous random variables, infinite, uncountably infinite. And so again, discrete, typically think of it as either finite or whole numbers. Continuous as intervals. For discrete random variables, the sum of all probabilities has to be 1, and all probabilities have to be between 0 and 1. You have your expected value. Classify each as either discrete or continuous. Number of missed calls on a phone between 8 and 9 p.m. What do you think? Would that be discrete or continuous? That's discrete. And it's whole numbers. Again, as a general thumb, discrete usually you're counting something, and continuous is measuring something. Right? Time in minutes to walk from dorm to class. What is it? You can have fractions of a minute, right? That would be continuous. Number of goals in a soccer game. And then mass of a metal sample. Is continuous. That was pretty straightforward. So we're given 4 tables, and we want to determine whether each one defines a probability distribution or not. Specifically, a discrete probability distribution. So let's start with A. Remember, 2 things that have to be satisfied. Easiest one to check, are they all between 0 and 1? All the probabilities, are they between 0 and 1? So remember, you're looking at the probabilities, which is P of X. They are all between 0 and 1. The second condition satisfied. Now all I have to do is check, do they sum up to 1? And what you might see is something like that, sum of all x's in x, which means just summing over all of your possible random variable values. Or, more simply, sum over little x. What do they sum up to?
One.
They sum up to exactly 1. This does define discrete probability distribution. Second one, again, easiest one to check, are all the probabilities between 0 and 1? They are. Now just check their sum. What does that sum up to? Oh, you make me sad. Then we plug it into a calculator. 65 and 20. That one's easy. 85. 85 and 15. It's 100. 100 plus 10 is 110. Not a distribution. Oh, this was really easy. Easiest condition to check. Are they all between 0 and 1? No. Probability of 2 is negative. So it's not a distribution. Even though, if you notice, they do sum up to 1. Probabilities between 0 and 1. They are? Good. Now check their sum. What does that sum up to? Not a distribution. Only A was. Fill the blank. So that is a valid distribution. So PMF typically used to represent a probability function. Get the exact terminology of PMF. Well, there are two things that we have to know about it. Let's call that little p. You have to have it be between 0 and 1, right? And we have to have that sum being 1. $40 and $30. 70 and 15.
85.
So 0.85 plus P has to be 1. What does that mean P has to be? What is it? 0.15. Now just check, does that satisfy condition 1? Yep. That's your value of P. Compute the mean and standard deviation. Now remember, the mean is the sum over all values of x times P of x. What's 0 times 0.1? 0. That's nice. 1 times 0.35. 0.35, that one's nice. 2 times 40. And 3 times 15. 35 and 45 is 80. 80 and 80 is 160. Our mean is 1.6. I'll relist it out later. Standard deviation, what we want first is variance, which means next thing we're going to calculate is E of x squared. Which is defined as the sum over all x of x squared times P of x. What's 0 squared? Times 0.1. 1 squared times 0.35. Oh, they were nice. What's 2 squared? Times 40. Make it easy. What's 4 times 4? Multiply that by 10 because it was supposed to be 40, not 4. Makes 160. What's 3 squared?
9.
9 times 15. We already know what 3 times 15 is. It's 45. 45 times 3. 40 times 3 is 120. What's 3 times 5? Now, what is 120 plus 15? 9 times 15 is 135. .35 plus 0.35 is 1.7. Right, so 170 and 160. 330. There's e of x squared. Our variance e of x squared minus e squared of x. .30 minus 1.60 squared. .60 squared. What is 16 squared? That's 256, right? So then just add a 0. Be 256. I'm sorry, 2 zeros because 10 squared is 100. Right, so 25,600. Should be 2.5600, or just 2.56. .330 minus 256. What is it?
74.
Variance is 0.74. Square root of 0.74. Got 0.860. Let's just say 0.86. There's the mean standard deviation for this distribution. Same thing. Something I didn't do that I probably should have done is to check to see if it's even distribution. That one was good. Would have sucked if it wasn't. Check again. Let's check this one. Is this a distribution? Yeah, that's a distribution. And if it's not a distribution, there's no point in trying to find mean or standard deviation. And so, mean, expected value. Sum over all x, x times p of x. Negative 2 times 10, negative 20. We'll look at that, minus 120. Plus 0, that's nice. And then plus 0.30. What is it?
110.
That. Negative 0.10. We are allowed to have negative expected values. That's find e of x squared. Before even starting, you should be able to determine what kind of value we're going to get. This has to be positive. And p of x is always positive, x squared is always positive. And 4 times 0.10, 1 times 0.20, 0 times 0.40, 0 times 0.30, 0.90. Okay. Variance e of x squared minus e squared of x. Again, variance should always be positive. What is 10 squared?
110.
What's 10 squared?
1.1.
10 squared is 100, right? So 0.01 is 0.1 squared. Gives you 0.89. Standard deviation is the square root of that. About 0.943. And just make sure you can get that on your calculator. There's the mean standard deviation for this distribution. Ticket costs $2. Out of 1,000 tickets, there is one $500 prize, 5 $50 prizes, 50 $5 prizes. Let X represent the player's net win. Evaluate and interpret the expected value. Expected value, remember it's the sum X times P of X. X is what? Net win. So if you want to, you can also first just form your table. Let's start with the smallest value of X. What is the smallest net win?
2.
How do you get 2?
No.
How do you get 1? So instead, think of it this way. What is the smallest prize? Is it? the smallest prize? 0. You don't win anything. But you spent $2. So what's your net win? -2. Right, because you're out $2. What is its probability? It'd be 1,000 minus 56 out of 1,000, right? So there are 56 prizes. So it's 1,000 minus 56. 944. And you can easily do that, right? Divided by 1,000, it's just 0.944. What's the second smallest prize? The smallest was 0. What's the next one? What is it? So what's the prize? What's the winnings? Just 5, right? Net winning is then what? You win 5 but spent 2. What is your net? Just 3. With what probability? 50 out of 1,000. Which is 0.05. What is the next value that X can take on then? So second highest prize. What's your net winnings?
8.
With what probability? How many $50 prizes are there?
55.
Hmm?
55.
How many $50 prizes are there?
5.
Out of how many total tickets?
1,000.
What's 5 over 1,000?
0.005.
And what is the final value X can take on?
500.
That's the winning. What's the net?
198.
With what probability? What is it?
0.05.
There's only one.
1,000.
So 1 out of 1,000. 0.001. So how many total prizes are there? 1 plus 5 plus 50, right? Out of how many total tickets? So if there's 56 winners out of 1,000, how many non-winners are there? 1,000 minus 56. which is what, 9, it's 944. So 944 out of 1,000 is the probability. That would be your PMF. Right now, it's easy to determine the expected value. No. 48 times 0.005. $498 times 0.001, that's easy. Sum them all up. -1. Now, what does that mean? On average, each ticket, you're losing $1. By the Powerball, look on the back of the ticket, it actually gives you the odds. I think it's still on the back of the ticket. If not, you can easily look it up. Calculate the expected value of the lottery tickets. You can also calculate how many tickets you have to buy to be guaranteed the jackpot. I promise you, you're spending way more money than what the jackpot actually is. Powerball is what? It's 5 numbers. What do the numbers go from? 1 to 70? 69? I think it's 1 to 69. Yeah. Might be 65. It used to be on the back of the ticket where it gave you the odds of each prize. If not, they're actually required by law to disclose it on their website. Then they moved it to their website, but they are required by law to disclose it. Prizes and odds are right there. So if you go to the website, it does show you the odds. They're required to. But Okay, it is 1 to 69, and then 1 to 26 for the Powerball. Yeah, it's very low odds, isn't it? There are 35,600,000. No, I'm sorry, 350 million. No, that's wrong. $35,064,160,560 different combinations, which means that's how many lottery tickets you have to buy to be guaranteed to win the jackpot. Each ticket costs $2. $71 billion to be guaranteed to hit the Powerball. You have a better chance of getting struck by lightning twice in the exact same spot than of winning the jackpot. Also, you might get less than half of the jackpot winnings. If you take the cash option, it's less. It's about half, and then taxes on top of that. You're getting about 40%, 30 to 40% of the actual jackpot. Device has probability of 0.08 of replacement, which costs $120, and 0.12 of repair, which costs $45. Otherwise, no cost. Let C be the company's cost. How much should the company charge for a warranty in order to break even? Right, so C is company's cost. Right, $0 with a probability of what? 0.80. Yeah. $45, probability of 0.12, and then 120 with a probability of 0.08. That 0 is not needed for this calculation. So company's expected cost. Would be that. $45 times 12. $540, right? And then 120 times 8 is 969.60. And don't forget units. Expected cost for the company is $15. So to break even, they should charge $15 for a warranty. Which means they're actually probably going to charge about $30 for the warranty and make a profit. That's why in general you shouldn't buy extended warranties. Because the company charges it to guarantee that they make money on it. Now, if it's something really important, it might be worth the extended warranty. I buy extended warranties on my computers because I kind of need them for work. But otherwise, I don't really buy extended warranties. Because of that, you're losing money on them. That is an introduction to discrete random variables. I think we studied one special type of discrete random variable called the binomial distribution. Which is Thursday. But there's a lot of different types of discrete random variables. If you take more advanced stat courses, you will study those in depth. So any questions on this stuff? I'll list this up here. Unit 2 test is due Thursday. That's on the regression and basic probability stuff. Second AI assignment is up. That's due Tuesday. That is just asking it to calculate probabilities. Pretty straightforward. And your second group assignment is now up, but that will not be due until the 20th. Leave that assignment. You're going to have 3 data sets to choose from. You just have to pick one and then perform the task. It's all about random variables. So at least get a start on that, look at it. Maybe pick the data set you want to use. Most of it you're probably not really going to do just yet. So I will give these out if you want to work on them.